This presentation discusses grinding techniques for sample preparation at MCL. I'm going to talk to you about two mills that we use, the McCrone Micronizing mill and the Retsch CryoMill. The McCrone Micronizing mill is used for reducing specimens to fine powders. Usually they're under 5 microns finally, with the goal of minimizing preferred orientation and creating uniformly sized powders from samples that have an uneven size distribution in different components. This technique was specifically developed for the preparation of samples for X-ray diffraction. This is a picture of the McCrone Micronizing mill. This is a jar that is loaded into the mill, and this cap is put on top. Most of the grinding is done in a few minutes, but the grinding times are from 1 to 30 minutes. We have 3 different materials we use for grinding. Here is alumina balls with the Mohs hardness value of 9, zirconium oxide with a Mohs hardness of 11, and agate with a Mohs hardness of 7. This little media loading jig is put into the container, and the balls are lined up in all of its channels. So we take the jig out and put the sample, wet or dry, on top of the balls, and then put the cap on. And then that is what's loaded into the micronizer to create the fine particles. The advantages of the micronizer are that it can reduce the particle size to usually less than 5 microns. You do not lose any crystal structure. It minimizes preferred orientation. It can be used wet or dry, and it can be used with a variety of materials. The disadvantages are that the sample powder must be below 0.5 millimeters to begin with, so coarse powders do not work in here. You need a minimum of 2 milliliters of powder sample. So if you only have a tiny sample of powder, you can't use this technique. It is not good for grinding polymers, mostly because it heats up inside the chamber. You can do wet grinding, but you can't use acetone because acetone reacts with the bottle and the lid. And the grinding container wears easily. The applications, these are primarily used, as I said, to prepare fine uniform powder to be measured by X-ray diffraction, and also to prevent preferred orientation in powder samples, particularly in mineral specimens. The technical specs are it's a compact benchtop-sized model. It has adjustable grinding power in 4 steps that can go from 1,000 to 5,000 RPM, quiet operation, and it's easy to clean. The other mill I'd like to talk to you about is the Retsch CryoMill, which is a cryogenic mill. And this is what that looks like. It's ideal for grinding tough, elastic, heat-sensitive materials and samples containing volatile components. Cryogenic grinding involves the embrittlement of the material by liquid nitrogen in this case, which substantially improves the breaking behavior. And this is what it looks like in operation. There are available grinding jar sizes. There's 25 milliliter zirconia and 25 milliliter Teflon, and they have 15 millimeter media inside them. There's a 50 milliliter stainless steel jar with 25 milliliter media. This is a picture of the ball, the stainless steel ball. These are smaller 15 milliliter balls. And this is the variety of jars. They have screw top lids, which prevent any kind of leaking. The majority of the materials will be milled in the 50 milliliter chromium stainless steel jar with a 25 millimeter stainless steel ball. Zirconia or Teflon are used if you are worried about contamination, or if your starting powders are greater than 1 to 500 microns. The advantages of the Retsch CryoMill: it's compact. It is located in the hood in room 008, as is the Micronizer mill. This can grind metals, polymers, inorganic materials, bacteria, food, and many other substances. There's continuous grinding with no contact with the liquid nitrogen, and will maintain liquid nitrogen temperature throughout even very long runs. The disadvantages are you can get contamination from the stainless steel media, so we can use other jars and media. And the preparation and cleanup time is very long because the liquid nitrogen first has to cool the whole system, and then the whole system has to warm up before you can remove your sample. The applications, as I said, are biologic materials, materials with elastic behavior, materials with volatile species, and sticky or tough food samples. Here is a picture of gummy bears before they were put into the CryoMill. They were cut into smaller pieces to load, and here they are after they've been CryoMilled. The technical specs are: we have a material feed size of 8 millimeters. The final fineness is 5 microns, about. There's a maximum batch size of 20 milliliters. The speed goes from 300 to 1800 revolutions per minute. You can do wet or dry cryogenic grinding, and the grinding time is anywhere between 30 seconds to 99 minutes. If you would like to use either of these mills, please contact the Materials Characterization Lab. Thank you.